Good morning, my dear students. In this video presentation, again, we'll discuss some more problems meant for class 12 of CBSE. As I already told you, each of the problems will be very useful to you and apply your mind in understanding each and every step being discussed here, and you'll be able to do definitely extremely well in your board examination. But you need to think an answer before starting with any of the answers in your board examination. The first question meant for today goes like this. Bag contains 4 balls. 2 balls are drawn at random, one after the other without replacement, and are found to be white in color. What is the probability that all the balls in the bag are white? I repeat, I have done such a problem, but earlier I might have used simultaneous selection. There are 3 different ways of interpreting the result over here. Both the balls can be selected simultaneously. 2 balls can be selected one after the other without replacement, and 2 balls can be selected with replacement. For example, if there are 7 red balls and 3 blue balls, let us say, if 2 red balls are chosen one after the other with replacement, I'll write it as 7 by 10, it is 1 by 10. If it is done without replacement, 7 by 10, it is 6 by 9, I'll write. The chosen ball is not dropped back. Therefore, number of balls get reduced to 9. Number of red balls will get reduced to 6. I'm giving you a situation. Okay. Therefore, in the case of only simultaneous selection, I'll be using combinations. In the case of selection, one after the other with replacement, without replacement, I am not supposed to use combinations. But the answer will be the same in the case of simultaneous selections and one after the other without replacement. Therefore, the guides are using combinations for the second application, selection one after the other without replacement also. It is better to avoid such a situation. Remember that particular. That's the reason why I have taken this problem. I repeat the question. A bag contains 4 balls. 2 balls are drawn at random, one after the other without replacement, and both are found to be white in color. What is the probability that all the balls in the bags are white? See here, I'll take 3 different situations. Let E be the event of having 2 white balls, 2 non-white balls in the box, in the bag, sorry, bag or box, whatever it may be. Let E2 be the event of having 3 white balls, 1 non-white ball, and let E3 be the event of having all 4 balls to be white in the bag, Let E be the event of selecting 2 white balls one after the other without replacement. Without replacement means I'll take 1 ball, I'll put it aside, I'll take another ball. That's the meaning of without replacement. Now P of E1 is equal to P of E2 is equal to P of E3. Each is one of those 3 possibilities. I'll get it to be 1 by 3. Now P of E bar E1, from the first situation I'm getting 2 white balls. Now for initially the selection of white ball is 2 by 4. The chosen ball is kept back. For a number of white balls gets reduced to 1. Number of balls gets reduced to 3. Therefore it is reduced to anyway 1 by 6. Now P of E bar E2. From the second situation I am selecting 2 white balls. Initially there are 3 balls. Then I have 2 by 3, which is again reduced to, here of course it is reduced to 3 by 6, let us say. Am I right? 3 by 6. Okay, then P of E bar E3. Just for calculation purpose, I am having denominator 6 as it is. Okay, just listen carefully. Here 4 by 4 into 3 by 3. The chosen ball is not dropped back, therefore I'll get 3 by 3. It's the same as 1, which is 6 by 6, let it be. Now E1, E2, E3 are mutually exclusive and exhaustive. Therefore, Bayes' theorem is applicable. Bayes' theorem is applicable. Now, P of E is equal to P of E1 into P of E bar E1 plus P of E2 into P of E bar E2 plus P of E3 into P of E bar E3. This rule is called total probability theorem. Total probability theorem. Okay, let me substitute the values. 1 by 3 into 1 by 6 plus 1 by 3 into 3 by 6 plus 1 by 3 into 6 by 6. This is reduced to 10 by 18. 6 plus 3, 9 plus 1 is 10. Now required probability is P of E3 bar E. I choose two balls, both are white. What is the probability? All the balls are white in color. Therefore, this is P of E3 intersection E by P of E. Can be written as P of E bar E3 into P of E3 divided by P of E. See here, use this rule P of E intersection E3 by P of E3. Cross multiply P of E3. Here substitute the values. P of E bar E3 is 6 by 6. P of E3 is 1 by 3 divided by 10 by 18. Let me just write the final value here. This is reduced to 6 by 10. Answer is 3 by 5. Final answer happens to be 3 by 5. I repeat the whole process. Let E1 be the event of having two white balls, two non-white balls. There are 4 balls given in the box bag. It is already given. The remaining 2 balls can be of any color. Therefore, I write it as non-white balls. I am not bothered about the colors of the remaining 2 balls. Let E2 be the event of having 3 white balls and 1 non-white ball in the bag. In the bag, you can write. Let E3 be the event of having all 4 balls to be white in the bag. Let E be the event of selecting 2 white balls, one after the other without repeat. One of the videos I might have done simultaneous selection. Here, it is given in a different way. That's why I am doing a similar problem here. P of E1 equal to P of E2 equal to P of E3 is equal to 1 by 3. Those are one out of those 3 different possibilities. Now for each is equal to 1 by 3. Next, P of E bar E1. From the first situation, I am selecting 2 white balls, one after the other without replacement. 2 by 4 into 1 by 3. Chosen ball is not dropped back. That's the meaning of without replacement. Number of balls gets reduced to 3. Number of white balls gets reduced to 1. Here 4, I'll get 1 by 2. Therefore 1 by 6 is a reduction. From the second situation, I'll get 2 white balls. 3 by 4 into 2 by 3 is reduced to 3 by 6. From the third situation, I am getting 2 white balls. Initially, there are 4 balls, 4 by 4. Secondly, there are only 3 balls, but all the 3 are white, 3 by 3. It's reduced to 6 by 6. 1 by 1 can be written as 6 by 6. It's a sure event. Probability is 1. E1, E2, E3 are mutually exclusive and exhaustive. There is no common element as far as the events are considered. And some of the probabilities 1 or E1 union E2 union E3 is yes. Either way you can say that's the meaning of exhaustive nature. That's the condition for applicability of Bayes' theorem. Now P of E can be written like this using total probability theorem. Let me substitute the values. 1 by 3 into 1 by 6 plus 1 by 3 into 3 by 6 plus 1 by 3 into 6 by 6. 6 plus 3, 9 plus 1, 10, 10 by 18. A required probability is P of E3 bar E. I am having 2 white balls chosen. And what is the probability? All the balls are white in color. P of E3 intersection E by P of E is reduced to P of E bar E3 and P of E3. Just apply conditional probability here. P of E intersection E3 by P of E3. Cross multiplication will give you the numerator, which is reduced to 6 by 6 to 1 by 3 plus 10 by 18. 18 gets cancelled. 6 by 10 is nothing but 3 by 5. 3 by 5 is the final answer. 3 by 5 is the final answer. It's not at all difficult. I already told you in one of the videos earlier, it's as equal as Box A has 2 white balls and 2 non-white balls. Box B has 3 white balls and non-white ball. Box C has 4 white balls. There are 4 balls, all are white. One box is chosen at random and 2 balls are chosen from it, one after other without replacement. And both are found to be white in color. What is the probability that it is from box C? That particular situation is given in a different way. Let me repeat. Box A has 2 white balls and 2 non-white balls. Box B has 3 white balls and 1 non-white ball. Box 3 has 4 white balls. There are 4 balls, all are white. One box is chosen at random and 2 balls are chosen from it, one after the other without replacement, and both are found to be white in color. What is the probability chosen from box C? That particular situation is given in an easier way, quicker way in this particular problem. Here, these are 3 different possibilities. There I am choosing one box out of those 3, 1 by 3. Rest of the things are as it is. Same manner the answer will be done. The same manner I will get the final answer to be 3 by 5. Final answer will be automatically 3 by 5. It's not at all difficult to follow. I'm taking this much pain to explain for put your concentration, concentrate fully and then try to understand. Okay, without understanding the concept behind the problems, don't give importance for commenting about the handwriting, etc. It's not going to help you in any way. Okay, if you apply your mind, you'll be able to follow what I am writing. It's not at all difficult to follow. I'm explaining, I'm writing, therefore you'll be able to definitely follow what I am writing. Therefore, do the right thing and utilize each and every video in a nice way. Okay, now next question goes like this. Solve. Just see here, x e power x by y. Let me just write down x e power x by y. Y e power x by y. Y e power x by y dx is equal to x e power x by y plus y square into dy. Y not equal to 0. This is the question given to you. Now I am taking the question as it is. Here I mean to say dx by dy happens to be x e power x by y plus y square divided by y e power x by y. Can be written as x by y into e power x by y plus y by e power x by y. Am I right? Is it clear? Yeah. I am dividing by y individually. One second, there is some problem here. X by y, lambda x, lambda y, lambda y. X e power x by y plus y square. Y e power x by y dx is equal to x e power x by y plus y square into dy. Y not equal to 0. Now dx by dy happens to be x e power x by y plus y square by y e power x by y. I am taking this y up. For x by y e power x by y plus y divided by e power x by y. Okay. Here everywhere it's of degree, same degree. Dx by dy here, sorry. Am I right? Am I going wrong elsewhere? Sorry, there is a small interruption in the middle. Actually, this doesn't come under homogeneity because here the power is 2, here the power is 1. It doesn't come under homogeneous case. Let me just think about it in a different manner. Just listen carefully. It's totally a different problem, but again, it's not at all difficult. Let me just see here. Here I mean to say y e power x by y dx by dy is equal to x e power x by y plus y square, which implies y e power x by y dx by dy minus x e power x by y is equal to y square. Let me take e power x by y as common. Y dx by dy minus x whole divided by y square is equal to 1. Now listen carefully. Now I am going to use a suitable it's totally a different problem. Just listen. E power x by y is equal to t. Now let me differentiate with respect to y everywhere. I mean to say, okay, e power x by y into here the power to apply division rule. It will be y into dx by dy minus x into 1 by y square is equal to dt by dy. I repeat, I am differentiating throughout with respect to y. Right hand side becomes dt by dy. Left hand side for e power x by y it is e power x by y. For x by y, denominator y into derivative of numerator with respect to y dx by dy minus numerator x into derivative y with respect to y is 1 by y square. This is nothing but my LHS of 1. Therefore, 1 implies dt by dy happens to be 1, which implies dt is equal to dy, or integral dt is equal to integral dy, which implies t is equal to y plus c. But my t is nothing but e power x by y. E power x by y is equal to y plus c is the required general solution. It is the required general solution. It's totally a different problem. Let me just explain once again. Y e power x by y dx is equal to x e power x by y plus y square into dy. I am writing it this way, but it doesn't come under homogeneous case. By homogeneity means each and every term will be of same degree. Here power is 2 is greater. Therefore, I'll just cross multiply here and bringing minus x e power y x by y here. I take e power x by y as common. Y dx by dy minus x by bring y square down. Aim it as equation 1. I put e power x by y is equal to t. I am differentiating throughout with respect to y. I mean to say, right hand side becomes dt by dy. Left hand side becomes e power x by y into y into dx by dy minus x into 1 by y square. This is totally my LHS of my equation 1. Therefore, my equation 1 becomes dt by dy is 1. Integral dt is dy. T is equal to y plus c. T is replaced by e power x by y. For e power x by y is equal to y plus c is the final answer. That will be the final answer. Anyway, it's totally a different problem. Just think over it. It doesn't come under homogeneous case. Okay, initially I started doing it like a homogeneous case. It's not a homogeneous problem. Now, I'll check for the answers, and as usual, I'll upload accordingly. Thank you, students, for patient watching.